Hi, so this is a complete new video for a chapter where we try to find a way to solve forces for particles, sorry for that, to solve for particles which has multiple forces acting on it. Like for example, when we were in O levels, we saw these kind of problem where you had a box. Okay, this is known as Newton's laws of worked example. Okay, when multiple forces act on it, you have a voice. Let's say there is a person who is pulling this box with 3 Newton on this side, and there is a box that the person is pulling from this side, let's say with 1 Newton. So overall the resultant force here is right side we take always as positive and left side is negative. So 3 minus 1, so it's going to be a 2 Newton. So it's going to be a 2 Newton. Now this was very easy to solve because can you see this force is in horizontal direction, this force is also in horizontal direction, and we could solve this very easily. So 2 Newton, that means when it is plus 2 Newton, we know the object is moving towards right. Technically this arrow is supposed to be a bit longer since this side is more than this side. Okay, whatever. So this is problem number 1 we used to do. Then there are some problems we used to do where, let me just delete these. Okay, where we had a situation where multiple forces were acting but they were all in the same axis. Okay, like for example, horizontal, let's say you have 4 Newton, let's say you had 6 Newton, and this side let's say you have 3 Newton. Okay, in such cases what we would have done, since they both are at the right hand side, we would have taken both of them as positive. 6 plus 4, and by the way, these we don't know whether these bodies are in equilibrium or not, so we need to find whether they are in equilibrium or not. So 6 plus 4, okay, minus 3. 6 plus 4 minus 3 equals to 0. How much is it? Not 0, by the way. Okay, how much? 6 plus 4 is 10. 10 minus 3 is plus 7 Newton. So if it is plus 7 Newton, we know the object, there is a resultant force of 7 Newton towards the right over here. There is a resultant force of 7 Newton towards the right. Okay, so this object is actually accelerating. This object is actually accelerating. Why? Because it has a resultant force. Remember, any object that has a resultant force, okay, accelerates. It causes a resultant force, causes acceleration. Okay, so if there was, this is one of the way they would have given us in O level. Let's say there was another way. Let's talk about vertical forces now. This was horizontal and this was vertical. Now let's talk about vertical forces. Same thing over here. You have a box. Let's say you have air resistance acting of 3 Newton, and you have weight of let's say 5 Newton. Let's say. Okay. So in this case, we will take downward as positive and upward is negative, or upward as positive, downward as negative. It doesn't matter. We can take whichever side positive we want to, but we always take. I have a rule, but I will mention that later on. Okay. So in this case, let's say 5 minus 3. So that's like 2 Newton. So it's positive. We are taking downward as positive because we took 5 as positive and 3 as negative. Okay. So 2 Newton, it's said that means this object is moving downwards. Okay. And it has a resultant force. Since it has resultant force, it will accelerate downwards. Since it has a resultant force, it is this thing accelerating downwards. Okay. Now let me tell you something regarding this concept is that if we had horizontal force, we only had horizontal forces in our boxes. Horizontal, 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 horizontal. If it was vertical forces, they would have just given in vertical only. Vertical and vertical. They would not mix the force for us in O level. From now on, they will start giving mixing of forces. The kind of forces, some example I'll see. Look at this glider. Look at this glider over here. See, it has a 2 upward force. It has a force at an angle, and it has a force horizontal as well. How do you solve these kind of sum? Okay, let's start with the basics. Let me delete these things. Okay, so all these days, if there was horizontal, they would have just given us horizontal, and we have to just do plus minus. And if there was vertical, it would have been vertical, and we had to do plus and minus. That's it. Okay, and if there was a resultant force, if for example, if the body, for example, if the body, let me just delete them. If the body had a balanced force, this is known as balanced force. This is 3 Newton, and this is also 3 Newton. For example, if the body had a balanced force, and what is the resultant force here? The resultant force is 0 Newton. That means this body is in equilibrium. This body is in equilibrium. Just remember this. Okay. If the forces is 0, overall force is 0, this body is in equilibrium. Okay, now let's learn, excuse me. Okay, let's learn what happens when you have a particle and it has a force. When you have a particle, it has a force in horizontal direction and vertical direction. You cannot just minus them. You cannot say, oh bhaiya, 4 minus 3, 1 Newton. No. All this time, if it was horizontal, everything was horizontal. If it was vertical, everything was vertical. But now they have mixed horizontal and vertical forces. So this is how you do it. I already uploaded video how to draw vectors in Google Drive. Okay, I think I already gave you guys the link. If I didn't, do ask from me. Okay, so now, so out of this two, you can choose any force. Do you want to choose 3 Newton first? Do you want to choose 4 Newton first? Let me copy paste this in another concept and then let me draw it for you all. That would be better. Sorry, I need to take snapshot. Uh, so irritating. Okay, chalo then. Okay, paste. So this is the force acting on O. One force is going towards the right and one force is going towards the left. Sorry, up. So there is a horizontal force and there is a vertical force as well. So what do you do in such situations? In such situations, you do Pythagoras theorem. This is what you do. You draw the particle. Then you choose any one of this force over here. Okay. So let me choose. Okay. Do I have, wait, just exit bandicam drawing mode? No, I could, back in the days I could just remove this. Okay, yeah. Okay, okay then. So now this particular diagram, I chose 4 Newton first, so I will draw 4 Newton this side. Okay, can you see 4 Newton is towards the right? So my first 4 Newton is also towards the right. Where your first arrow ended, there you have to continue the next force. This is how you draw vector diagram. There are other ways to solve this also, but if you have only two forces, this is how you best to solve. And then you have 3 Newton over here. So I will draw 3 Newton like this. Okay, then I'm going to join, this is the start point and this is the end point. I'm going to join start point and end point. This is my resultant force. This is my resultant force. So in resultant force I will draw arrow mark, double arrow. This is 4 Newton and this is 3 Newton. Can you see these are the two forces acting on the object? One was horizontal, so I did horizontal, and from where the first arrow ended, from there I started a next arrow. So 3 Newton I started. 3 Newton is in vertical direction, so 3 Newton is in vertical direction. I would suggest all of you guys to see the video of vector diagrams. Okay, remember that. How do you solve this force now? To solve this force, just do Pythagoras theorem. It's going to be root of 4 square plus 3 square. Do this in your calculator, find the answer. So remember, if multiple forces are acting in different direction, you cannot just minus them. Okay, sometime you need to draw a Pythagoras theorem. Pythagoras this thing. You draw a right angle triangle. Then you have to find hypotenuse. Okay, now what I'm going to do in this video, I'll be teaching you guys M1 and Unit 1 vector chapter together. Okay, not M1 vector, huh? not M1 vector. M1 vector is completely different. Okay, we are going to do how to solve when multiple forces acts on an object, when there are angle forces, when there are straight forces, when there are vertical forces acting on an object. So remember, this has, I will be teaching initially M1, then I will go to solving sums for vectors. Okay, so let's do M1 sums first. Okay, okay, so these are the some two situation that has been given to me over here. Okay, so let me draw a boundary line over here. These are the two sums that has been given to me. I need to solve. Can you see this object? They say that it is accelerating on the right hand side. This is very important. It is accelerating on the right hand side at 2 meter per second square. Let me teach you guys something first before I do this sum. Remember, okay, um, the first thing, this object is not in equilibrium because it is accelerating. So remember, when the force is balanced, okay, the object is either at rest or it is traveling at constant velocity. So remember, if they say the body is in equilibrium, that means, what do you mean by when force is balanced? When the body is in equilibrium. When the body is in equilibrium, that means you have a balanced force. And when you have a balanced force, your object is either at rest or moving at constant velocity. So from now on, if they mention the object is moving at constant velocity, okay, this is how you write it. This is what you do. When the object is at constant velocity or at rest, or if they use the word equilibrium, okay, if they use any one of these words, that means your, this is what you do: sigma h equals to 0, sigma v equals to 0. That means, okay, that means total left hand side force equals to total right hand side force, okay, horizontally. And in vertically, same meaning. That means total upward force equals to total downward force. When do we use this equation? When your object is either at constant velocity, when your object is at rest, when your object is at equilibrium, or when your acceleration is 0. Remember, at constant velocity, acceleration is 0. Okay, so when an object is at rest, constant velocity, or equilibrium, this is your formula. Total upward force is equal to total downward force. Total left hand side is equal to total right hand side. But in this particular case, it is not in equilibrium. So therefore, the formula will change. So what will be the formula? The formula is going to be, okay, the rule says that whichever direction your acceleration is in, that direction all the forces are going to be positive. And whichever forces are in opposite direction of your acceleration, that side we are going to take it as negative. Okay, so if I want to make an equation for this particular, if I want to make an equation for this particular concept, okay, if I want to make an equation for this particular concept, this is what we do. Excuse me, let me just put it here. Oh, if I, oh god, sorry guys. Okay, I'm sorry. Okay, so this is how we write the equation. Okay, first, we know this body is not an equilibrium, so the previous formula we just learned is not going to work. This body, it is accelerating, that means there is a resultant force. Can you see it is accelerating in the horizontal direction? It is accelerating in the horizontal direction. That means the vertical direction is balanced, okay, because there is no acceleration given in the vertical direction. So therefore the vertical direction, the forces are in equilibrium, but horizontal direction, the forces are not in equilibrium. That means that means this is how you write it. Remember, whichever side acceleration is there, that side we are going to take positive. So x is positive and 4 Newton is going to be negative. Why? Because it is in opposite direction of the acceleration. Okay, so this is your resultant force in the horizontal direction. So in the horizontal direction, x minus 4 Newton is m into a. What is the mass? 2 kg. Mass is 2 kg. A, acceleration is 2. So x minus 4 is equal to 4. X equals to 4 plus 4. Therefore x is 8 Newton. So we have solved horizontal direction. Understood? Okay, so let me repeat again. Whichever side, it is accelerating in horizontal direction only, not in vertical direction. So vertical direction, they are in equilibrium. In horizontal direction, it is accelerating. If it is accelerating, whichever side is acceleration direction, that side is positive. In this case, x is positive and 4 Newton is negative. Okay, you're saying, okay, what we would have done if this 2 Newton was 2 meter per second square was not given to us, if it was not accelerating in horizontal direction, would x still be positive? That is completely up to you. Yes, I always take right side to be positive and left side to be negative. Okay, if there is no acceleration. But if there is acceleration, whichever side the acceleration is in, that side is positive. Okay, okay, so let's go to the next. Now we have solved it horizontally. sigma h. Now let's solve it vertically. We know vertically sigma h means total horizontal force. Sigma v means total vertical force. Vertically it's in equilibrium. And equilibrium, what did I mention you? Total upward force, which is y, equals to total downward force, which is 2g. So y is 2g. I hope all of you understood this. Let me do another one for you all. Okay. I think I will try to make 20 to 25 minutes of video each of them so it doesn't become a burden on you all. So let's talk about this particular situation. Here also it is accelerating. If it is accelerating, and how many forces? Vertically you have three forces acting, one, two, three, and horizontally you have two forces acting. And it is accelerating in horizontal direction only and not in vertical. So vertical direction is in equilibrium and horizontal direction is not in equilibrium. It is accelerating. Okay, and I also mentioned whichever side is acceleration, that side is positive. So 80 Newton is going to be positive. Okay, let me just write this a bit up. Okay, so 80 Newton is positive minus x Newton equals to m into a. Resultant force, you guys know, F equals to m into a. Remember this, here as I used it, F equals to m into a. F is the resultant force. What is resultant force here? X minus 4 Newton. Okay, so here what is x resultant force? 80 Newton minus x Newton is my resultant force. Mass, what is my force? 4 mass, and 4 into 2, 8. So 80 minus x equals to 8. So 80 minus 8, this 8 will come this side and x will go this side. 80 minus 8 equals to x. So that is going to be 72 Newton is equal to x. Let me see whether the answer for B part is correct or not. It is 72 Newton. Let's talk about vertical force now. So this is our horizontal force over. I already mentioned vertically it is in equilibrium, and if it is equilibrium, that means total upward force is equal to total downward force. Upward force, what do I have? Y equals to total upward force equals to total downward force. Downward force is 20 Newton and 4g. So 20 plus 4g. Okay. So 20 plus 4g, do it in your calculator, get the answer. I hope you guys understood. Let me do it. 20 into 4.8, 20 into 9.8. Remember, in M1 we take 9.8, not 9.81. 4 into 9.8. Got 39.2 plus 20. So that's 59.2 Newton vertically. There is a force acting over here. 59.2 Newton. Okay. So horizontally, in this case, the force acting is 8 Newton. X is 8 Newton. And here it is 2G. And vertically, in this case, the horizontal force is 72 Newton, the X. And vertically, Y is 59.2 Newton. Okay. I hope you understood this explanation. Now, let's go to the next one. Okay. Now let's do some all this time it was all horizontal here. Whatever we did is horizontal. Let's do some vertical question. Okay, so let's say let's do this. Okay, this is the only vertical question I'm going to do. Okay, so you can see invalid operation GDI code. Continue. Can't I write over here? Okay. You can see horizontally there are no forces acting over here. What did they tell us to find though? What did they tell us to find over here? What's happening suddenly? Oh god, where is it? Okay. Okay, so they said us to find in each of the scenarios the force acting on the body causes it to accelerate. So this body is not in equilibrium. As shown, find the magnitude of the unknown force P and Q. We just need to find the unknown force P and Q. We are doing this P part. So let's do this. Okay, so can you see the force here is acting only vertically? There are no horizontal forces here. Okay, and it is accelerating. So in this case, it is not in equilibrium in vertical direction. It is not in equilibrium in the vertical direction. It is accelerating. So therefore, the formula I already mentioned, whichever side is positive acceleration, that side is positive. So this becomes positive. So 4g. This is also positive because 10 Newton is also downwards. 4g plus 10 minus p, because p is opposite of the acceleration, so minus p is equal to m into a. Okay, so 4g plus 10 minus 8, the 8 will come here, minus 8, the p will go here, is equal to p. So do this in the calculator. 4g plus 2 is your answer. 4 into 9.8, that is 39.2 plus 2 is equal to p, that is 41.2. p is equal to 41.2. Khalas. Understood? Okay, so I hope you know how to solve these kind of easy sums. Okay, let me see, do I have to do anything much over here? You can try these sums on your own. You can just pause the video right now and try them to get the answer. Okay, now okay, you know what, let me do this sum for you all so you can learn a bit of this comes in physics. Look, I'm doing M1 here, but it is physics stuffs as well. So let's do another one. Okay, so here they said you have a tension acting and you have a 4g. So there are two forces in the vertical direction. Mass is 4 kg. They're saying that find the tension in the rope. We have to find this value of T. Okay, when the block move downwards, it is falling downwards. First situation with an acceleration of 2 meter per second square. So it is accelerating downwards. So remember, downwards acceleration of 2 meter per second square. As I said, whichever side is acceleration, that side is positive. So 4g is positive and tension is negative. M into A is 2. Again, 4g minus 8 is equal to tension. The T goes over here, 8 comes here. 4g minus 8. So 4 into 9.8, 39.2. 39.2 minus 8 is, so 9.2 minus 8 is answer 31.2. So tension is 31.2 Newton. Accelerating downwards. Okay, so A part over. Let's go to the B part over here. Oops, sorry. Okay, let me just, oh god, again. Just lock it. Okay, now I can rub it. Okay, so now next situation, it is traveling at constant speed. Remember, when something is traveling at constant speed, I already mentioned it, the body is in equilibrium, the forces are balanced. Therefore, it is at constant speed. At constant speed, acceleration is 0. When the acceleration is 0, total upward force is equal to total downward force. So when it is moving at constant speed, T is 4g. Remember that. This is the answer for B part, because it is traveling at constant speed. At constant speed, total upward is equal to total downward. It is constant speed in the vertical direction. There is no horizontal force given to us. Okay, so let's go to the C part now. If I go to the C part, deceleration. If it is deceleration, okay, it's falling down and it is decelerating. So let's say it is falling down, it is decelerating. Okay, if it is accelerating, the value will be positive. If it is decelerating, the value is going to be minus 0.5. Remember that. It is falling down, but it is decelerating. Okay, if it is accelerating, we would have used plus 0.5, but here it is decelerating downwards, so minus 0.5. But all the situation remains the same. What are the total upward force? Same here. It's not total upward or downward. This is not in equilibrium right now. It's not in equilibrium. So whichever side the acceleration is, that side is positive. So I'll take 4g as positive, and tension is negative because it is opposite direction of the acceleration, is equal to m into a. A is minus 0.5. I'm sorry for this. Okay, minus 0.5. So can I write 4g minus t is equal to minus 2? T on the other side. 4g minus 2, sorry, plus 2 is equal to t. So 4 into 9.8 plus 2. 41.2. T is equal to 41.2 Newton. Both understood? So it's almost like 25 minutes now of this. I'm stopping here, then I'll make part 2. Okay, with other explanation. I hope you guys understood till here.